All right, it's recording. Exercise 1E, composite functions. So, the way I think of it is a composite function is a function, and you're going to fill this in, within a function. Okay? What do I mean by within? So when you write your function notation, which you might have learnt in year 11, if you haven't, I'm going to show you slowly here. If I wrote the function f of x, which is the replacement for y, okay, so you might be used to in year 9 to 10 and maybe 11, you were using y equals x squared, for example. We're replacing that variable y with the f function bracket x. The reason why we use that because on your calculators, it tells us a bit more. It tells us that the y is in terms of x. Right here, it all says it in 1. So it says that this function f is in terms of x. I could have another function called g, and it's still in terms of x, or I could have another function h, and it's still in terms of x. How you did it back in junior, in year 9, you would have done it y1, y2, y3, and it would have been like that as an example. Okay, but that subscript is what we're moving away from, and we're using functions notation. Okay, so when we say, well, what's a function within a function? Well, let's say I said y1 was sine of x, right? And I said, let's take sine of x and put it within a quadratic, which is an x squared. If I take the sine of x and I substitute it into an x squared, what would that look like? This is what it will look like. It would be y is equal to, now instead of x squared, I'm replacing that x with sine of x. Okay, because the function's in terms of x, I'm replacing that x with a sine of x. So what do I get? I will get sine of x squared. Does that make sense? If I do it the other way, let's say I took x squared and I put it into the function's y1, then what I would get, so if I did it the other way around, if I said, let's put this in here, then what I would get now is I would get y is equal to the sine of, instead of x, it is now x squared. Can you see wherever the x's are, I'm replacing it with the function. So we call that a function within a function or a composite function. Okay, and a lot of things are inherently a composite function. For example, you might know root of x. You learned that from last year, square root function. And then you might have learnt 1 on x. If I asked you to combine these two, in fact, you can do one of the versions, which is sketch that. Okay, and even though, and eventually what will happen is you might have learnt the skills to sketch a square root, you learnt the skills to sketch a hyperbola, rectangular hyperbola, and then here you'll get functions that you might not have ever seen, but you should be able to predict what it should look like based on the properties that you know from these two. Now let's do a bit of analysis here. What do we know that square roots cannot be? Or what can't it have? Can't have negative numbers. We know that we can't square root negative numbers. So already, if I were to picture this, there should be no negative values on the x-axis. Okay, because right here, if I'm going to square root something, I can't have a negative number. What's the condition for a 1 on x? What's one of the things that you can't have then? 0. So x can't equal to 0. That's your asymptote, right? So that means this graph is also a 1 on, and I can't have root of 0. Over here I can. I could do square root of 0 over here. That's fine. But over here, if this was 0, 1 over 0 does not exist. So what I can say is already I know there must be an asymptote at x equals 0. Okay? And I know that it can only be on this side of the graph because the negative sides do not exist. Now, what does the function overall should look like? Well, it's a 1 over a number. A 1 over a number is still a rectangular hyperbole kind of look. The only difference is obviously that shape on this side will be different, and this one does not exist because I can't have any negatives. So it will look something like this. That's my prediction. Okay, so my prediction will be very similar to your 1 on x, and that's the kind of analysis they want you to get to by the time you learn all the functions and you learn odd and even functions. You use all the properties you know, and you can predict what they give to you. So they might give you, like your x squared plus x. That's technically sums of functions. That's a quadratic plus a linear equation. You can predict what it looks like, but now we know how to factorize and solve that. Okay? Now I'm tangenting off. The idea was just to get you to understand what a composite function is just a function within a function. So the first skill in your textbook, what they do is they get you to do what I just did with you here. Okay, they'll give you two different functions, and they'll say find f of g or g of f. Okay, now what is that of that I just described? Let's fill in some notes. Let's go down here. So let's let f of x equal to sine of x. So that's my one function. Think of it as y1 equals to sine of x. And let's say g of x, so that's a different function. Let's call that y2 if that helps you, x squared plus x. Okay. Then when they say FOG of x, this is the notation for it. That's a composite function, that little O there. What that really means is for your function f, you're going to substitute g of x in it. This is what it looks like. You're essentially saying, I'm going to substitute g of x into f of x. Okay, so fill that in. Whereas if you said g of f of x, what do you think that means? What does that mean now? Yes, Lachlan? Correct. That would mean that you take the function of f of x and you put it into g of x. So the first part of your textbook, the first skill they want you to know is, well, what's the equation look like then? So for the first one, if f of x is sine of x, then what I'm doing is I'm taking g of x and I'm substituting it into f of x. That's what I'm doing. So in the notation, you can see this is where x is. And what I'm doing is I'm taking this g of x, which is this, and I'm putting it in there. I'm replacing all the x's with g of x. But if I'm replacing the x's, this ends up being sine of g of x. But g of x is x squared plus x. That's what you're doing. Okay, so that's one of the first skills. Just being able to get the equation. Doesn't mean the equation exists. Sometimes there's issues, and that's what the difficulty of this exercise is will that work? If you type in your calculator on Desmos, will it sketch it? Okay, if it doesn't sketch it, why doesn't it sketch it? You have to fix it. Okay, so that's the skill. So here, let's do g of f of x. So have a think. You've got a function g, and you're substituting, instead of that x, I'm replacing f of x, and I'm going to put it in to where x is. So if g of x is x squared plus x, instead of all the x's, I'm now replacing it with sine of x. So my equation should be sine of x all squared, because that's my first part. And now I'm going to replace this plus x is plus sine of x. How's that feel so far? Make sense? Good? That's the first skill in your exercise book. Okay, so as you're doing all the questions, they'll say, find f of g, find g of f, or whatever it is, that's what they're trying to say. Okay? Now, here are some logical conditions, and I've got some pictures to show you so you understand why or how these conditions occur. For a composite function, f of g of x, hypothetically, to be defined, when they say defined, it just means it works. It means that if you put it on a calculator, they can sketch it, okay, because the function works. You put in x, which is a number, and then there's a y value once you calculate it. If it can't spit out a number, it means there's an error somewhere, okay? So that's what they mean by defined. It must satisfy, and how many conditions? There are only two. Two key conditions. The first condition is the most important one. Okay, and this one is in your notes when you're writing in your exams, you always got to define it. But depending on what this group is, because it's f of g of x, then it should be the range of g needs to be the subset of the domain of f of x, or f. Okay, if it was written the other way around, if you had a g of f of x, then the condition has to then be the range of f needs to be a subset of the domain of g. I find that when students don't understand this, they just memorize that. And so when I give them a function like that, they still stick with this. Okay, so that's why I like to explain, well, why is it that range of g needs to be a subset of domain of f? If you understand this concept, why this occurs, you understand what the exercise is trying to do. We're trying to get you to fix the domain. Because we need that domain fixed. We need this range fixed for it to work. Okay, and you understand what I mean too. Yeah? And then if that works, then condition 2 will apply. What's condition 2? The domain of your first functions, the domain of f, okay, will equal to the domain of g of f. Actually, I think I wrote that wrong. Fix that, sorry. It should be domain of g is the domain of f of g. So that's a misprint there. I got that around. Okay, and I'll soon explain why I know that was wrong, and I'll show you in a picture way so you understand why the two conditions must work. Okay, so these are your essential understanding. The VCA exams, if they did a composite questions, this is what they're trying to test you. Okay, that's what they want to know. Do you understand those two? Why does it work? So here's a explanation so you can see just below. I drew two machines. What goes in, what comes out, right? Input, output. Kind of like what you've learnt in psychology or science, like independent variable and then dependent variable. Same idea, yeah? Let's say f of x is your first machine, so that's your function. G of x is your second function. Okay, so you've got root of x, you've got 1 on x. I like those two because they've got simple conditions that you all already know, and you know the graphs and what it looks like. So when I say then f of g of x, that just basically means I'm substituting g of x into f of x. So this is the function I gave to you before. That's 1 on root of x, right? Now for this to work, there is a condition. There is a domain that it works, and there's a domain that it doesn't work, right? So let's fill in a couple of things here. Let's look at f of x. What's the domain for 1 on x function again? That's a rectangular hyperbole. What's the domain? Let me remember, Joe.
Yeah, all real numbers except for 0.
Very good. So you would say R except is backslash, not forward slash. Back then they used to penalize you. Now they don't because they're too nice. And then you got your braces, 0, and your braces. Okay, so curly brackets is called braces. So you're saying all real numbers, any number is possible except, so it's backslash, the number 0. Okay, so we know this graph, 1 on x, has an asymptote at x equals 0. It can take every number except 0, right? What about the range? What's the range for the function of 1 on x? Can I please have, let's go with Neil.
Real numbers besides 0.
Very good. Same thing as well. So there's a vertical asymptote. There's also a horizontal asymptote. So it's R except 0. Let's go with the next one. Let's go, Alex. What is the domain for g of x, which is a square root function? What's the domain? Perfect. So you can write it like including 0 all the way to infinity. And then the range. What is the range for this? Let's go with Noah.
The range is the same thing. It's square bracket 0 to infinity.
Perfect. Okay. Now here's a logical explanation as to why that first condition is important. So let's have a look. I said that I'm substituting root of x into f of x, right? And then this is my actual function I want to sketch. But here's a couple of things that we can see. If I write this out, f of g of x actually means this. F of g of x, like that, right? That means when you substitute a number into this function, what gets solved first is g of x. That gets solved first before you do f of the function. Get me? So you square root it first before you do 1 divided by whatever that number is. So let's say I pick the number 1. So if x was 1, so this is the domain of g. Domain means you choose the x value. So I'm going to choose the values to fit g. So this is my g of x function. That's the first thing that goes. It goes in and it does root of 1, right? And then when it square roots 1, it spits out a number. That's your y value, which is g of 1. What's g of 1 equal to? 1. And then I take that 1, okay, so now that I've solved it, root of 1, I then put it, that's now my domain for f, right? So that 1 has to go into this domain, and the domain for your 1 on x is, it says, I can take 1, I just don't take 0. 0 is a problem. But I take every other number, so I'm like, cool. Enters into that machine, and then f of x goes, sweet. I'm happy with you. I'll take 1 on 1, and it spits out 1. Okay, so this is an example where it works. Can you think of an example where it doesn't work? Lachlan.
0 in the top.
Root of 0. So the first one works. First one works, spits out. G of 0 gives you 0. But then 0 needs to fit the domain for the second function. But we already said before, it takes all numbers except 0. So that one doesn't work. Okay? So what we see now is that what works for g of x did not work for f of x But you realize what the condition was. The condition was whatever you spit out was key. What you spit out is the range. That's why they say range of G needs to be a subset because it has to fit whatever the restrictions are here. Otherwise, it won't go in. So to go in, it needs to be a subset. It needs to fit the domain of F. That's why I was saying before, in this condition, it depends on what the function is. If F of G, well, G comes first before F. That's why the range of G needs to fit the domain of F. But if it's the other way around, if it was G of F of X, well, F comes first. That's why the range of F, what spits out from F, needs to fit out into domain of G. Does that make sense? Okay, because that's literally the essence what they're trying to get you to do. And so what you'll find is as you're doing the questions in the exercise, the later questions, what they'll do is you need to fix, at some point, the range is a problem. So you'll see in this group here, that does not, the range of G does not fit this. Because if you look at this pictorially, if I highlight these two, this is the key. Oh, sorry, not those two. This is key. If I put on a number line for you to see, G of X, the range of G of X is 0 to infinity. So this is what it looks like. 0, inclusive, to infinity. Domain of F of X, that's all real numbers except 0. So except 0, so you've got an open circle. It goes like this. This is part of this. It's true. Most of all of this is fitting into the very first graph. We're saying this G, range of G, needs to fit domain of F, which it looks like it does, but there's only one spot that it doesn't. Right here. And so when you fix it, what you need to fix is, well, how do you fix the range of G? You don't want a 0. You don't want the Y's values to spit out a 0. You don't want that 0. Then you have to affect the domain here. And that's what they mean in your exercises. They say fix the domain or change the domain or call it G star, whatever it is. What they're trying to say is, what numbers, what do I restrict here? Because initially you said domain is 0 to infinity. So what do I need to fix? Well, I don't want that 0 anymore because that 0 doesn't work. That 0 breaks the code. Don't put the 0. That means I will never spit out a 0. That means every other number should work. So from here, the answer would be fix this. How do you fix it? Don't include 0. Include every other number. And that's your new domain for G. That's in the most simplest form of explaining what composite function is and what exercise 1E is trying to do. Okay? The complication is not all graphs will be as easy as what I just did, where you just fix one bracket. You'll then have to look at a graph, you have to look at the domain, you have to do some calculations to figure out where. And the problem is where students find confusing is you need to fix the range, but to fix the range, you have to fix the domain. That's what's confusing for a lot of students. Okay? And then depending on if you can graph or not, if you aren't able to graph, you can't see the range and the domain. That's where it's difficult. Okay, but if your algebra is strong and you can sketch, then what we're doing now is going to be easy. Cool? So that's the theoretical part. All right? Here we go. Let's do some examples then. Let's do some examples so that you get an idea, and I'll leave that to you. What? Is there not another page? Was that it? Why didn't it come up? I must have accidentally deleted it. That's all right. I'll just insert it again. Here we go. Exercise 1E. No, this is not. Year 12. Topic resources. 1. Notes. E. There we go. All right. Whoops. All right, let's do this one problem, and then you have the rest of the session for yourselves, and I'll walk around to see who I can help with, okay? Let's do an example. So I chose question 8 so that you have the practice to fix the domain, okay? So this is the key exercise that you want to understand. So from here, let's look at what they've given you. They've given you a function f. They told you the domain of this function is negative infinity up until 3, and the function is a linear graph, 3 minus x. Okay, so 3 minus x is the function, so I know the domain is negative infinity to 3 inclusive. The second function, which is g, g is an x squared minus 1, so it's quadratic. Okay, so g is a quadratic graph, and it says the domain can be any number, so there's no restrictions on it. So I can see is this is R, great. Now this is what I meant, if you can sketch or not. If you can't yet, use your calculator to picture, but eventually you have to be able to sketch all these graphs without using a calculator. Okay, so when I look at that, I already can see for a linear graph, for example, so for f of x, you've got a y-intercept at 3, and the x-intercept at 3 as well, and there we go. That's what I'm seeing, right? And then I look at this, x squared minus 1, I can see it's down by 1, that's minus 1. As a turning point, negative 1, 1. That's what I'm seeing. So you need to be able to sketch, no matter what graph they're giving to you, you should be able to do that like visually or just by hand. If you can't yet, start using a calculator to visualize it, or use Desmos, type it in, visualize. Okay, because the essence is to learn how to do composite functions, not sketching. All right, so I've got these two graphs. Sweet. One has a restriction node. This one says negative infinity up until 3. So that means when x is 3, the y value is 0. So that means my graph here I've drawn is not fully correct. It should only go from this top all the way down, and it stops here. But it goes on infinitely. Okay? So that means if I looked at this graph for the first one, that's for f. Clearly, domain is negative infinity to 3, but my range is clearly from 0 inclusive to positive infinity. Then I look at my quadratic graph, which is g of x. G of x, my domain was all real numbers, but my range clearly is from negative 1 to infinity. Okay? So that's the first step, being able to tell the domain and the range and then start to visualize it in your head. You don't have to draw it out in a table. I do it in a table so it's clear for you to see. Okay? Now, what are they asking you to do? They want you to figure out f of g of x. That means you're taking g of x and you're putting it into f of x. G of x occurs first before f of x. So that means this is g of x, then this is f of x. Okay? So if I'm taking x squared minus 1, I put it into my linear equation, I should get 3 minus x squared minus 1. So if you simplify that, that becomes what? Double negatives is positive, so that's 4 minus x squared. That's what you get. Okay? So I just skipped a couple of steps there. Expanded the brackets, negative x squared, double negatives becomes positive 1. 3 plus 1 is 4. And I've got 4 minus x squared. Okay? So that's my composite function. That's the first part. They'll ask you, show that f of g of x is not defined. Well, you can already see, how do we prove that it's not defined? Well, actually, I drew the graph for you guys already. Oh, I didn't have to draw it myself. I already did it. What we can see is, for it to not be defined in part A, when they say show, how do you show? Back in methods, when we say show, what do they want you to do? Yes, love. That's one way. You can do multiple examples, which you can pick random points, but they're looking probably for a more technical explanation.
To show all the working out how you get to that statement without using the statement initially.
That is correct. You have to show all the steps. Now, what's the thing that we need to prove that's not going to be true? Because remember, what's Vika trying to test you? Yes, Noah?
The range of g is not a subset of the domain.
Beautiful. Okay, so this is where if you were to do an exam and you needed to show, well, the first thing is, when will f of g of x be defined? Back to the first condition. First condition says it is defined if you've got f of g of x, range of g needs to be a subset of domain of f. Then it's defined. So you need to prove that this is not going to be true. So here's your statement. You start out writing out, well, for it to be defined, for f of g of x to be defined, range of g needs to be a subset of domain of f. Let's see if that's true. What's range of g? Well, we already got range of g as negative 1. What's going on there? Whoops. Negative 1 to infinity. And domain of f, which we've got negative infinity up until 3. For those who can't visualize this, I'm going to draw a quick number line so you can see. 0. Let's go g of x, which is negative 1 to infinity. So negative 1 inclusive to positive infinity. That's my G. That's the range of G. And then f of x, the domain of f of x, which is negative infinity up until 3, inclusive. Now we said range of G needs to fit domain of f. Does this fit? Fits parts of it. Which parts don't fit? Above 3. So you can see, if I had to take this purple line and then try to fit it with the green line, there's a bit that's missing. This bit. That bit does not fit in the green line. That's what we mean by subset. Subset needs to fit exactly. Okay, it needs to overlay a bit or whatever it is, but it needs to be a part of the green line. This part is not. This is the issue. This is the problem from here, 3 onwards. When 3 onwards, anything greater than 3, the other way. Greater than 3 is a problem. So what I'm saying is, in your quadratic graph, because range of G, -1 to infinity, which parts are the problem? Range of G, -1 to infinity, I said I can't have 3 and beyond. That means on your graph, I can't have range from 3 and beyond. That means from here and here needs to be eradicated. This is where you fix it. So how do you fix it then? I only want from this point, which is here, to this point, which is here. Can you see that? So I just need from here, and I need from here. That's the new domain. This is the new domain, not R. R is every number, hence why it shoots up. But I only need it from this point to this point, which is those 2 endpoints. So how do you do it? Sub what? 3. You need a sub in. So remember, you're wanting the y value to be 3 at maximum. Yeah? And then anything beyond 3, you also don't want. So 3, when will the y value equal to 3? And this is where you do your calculations. That's what I meant. You fix the domain to fix the range. The range needs to fit the domain of f. That's what you're trying to do. And that's what's confusing for a lot of students at the first step. Drawing it helps you to visualize it, or you can do it all in your head. It's possible. I'm just showing you explicitly. Okay? So from here, if I had to answer the question, I didn't want the range from 3 onwards, and graphically I already just showed you pretty much from this point and this point onwards, I don't want that line, I don't want this line, then it will work. So that means I need to figure out what x value will give you 3 and what x value over here will give you 3. And like we got the equation 3, it was g of x is equal to x squared minus 1. So then that means you need to solve 3 equals x squared minus 1. Add 1 on both sides, you get 4 equals x squared. Root of 4, what's the answer? Not just 2. Plus minus 2. Remember, when you square root, there's always a plus minus, and graphically it makes sense as well. There should be a -2 and a +2 here. So what am I trying to say? I'm trying to say at this particular point, when x is -2, I get 3. And then over here, when x is +2, I also get 3. So the domain for G was initially any number. The problem with any number is that eventually you're going to get 3 and above. You don't want a range of 3 and above. So we fix it. We say, okay, well, let's write the new domain, which they do a star or asterisk on it. And we say, well, we now know if 3 is the maximum number you can get to, well, then -2 and 2, that's where you reach 3. And everything else in between will fit. So hence, I now say, I want it from -2 to 2. Now you've got to be careful here. Do you include the -2 or do you exclude the -2 and the same thing with the 2? Do you include or not include? Either way would work, but if you want the maximal domain, usually ask what's the maximal possible domain. Well, remember, to fit, you can have 3. There's nothing wrong with having 3. Yeah, so the range could equal to 3, and as long as it doesn't pass 3. Whereas if this was open circle, if this originally said not include 3, then you better make sure this does not include 3 as well. Okay, so that's what I mean. So when you write the intervals, just be careful. Are you including or not including? That would be at the level of Year 12 exams. When you're doing in textbooks, they don't do that. But the Year 12 exams, they'll add on that little extra detail. They put an open circle, and you need to notice that. Okay? So in our case here, maximal domain, this would make it work. So what I'm trying to say there is we fix the domain. This is no longer R. If it was -2 to 2 inclusive, we know no matter which numbers you pick for the domain of G, it will spit out the final answer. Hence, whatever you put in for domain of G is also the domain for the composite function, and that's condition number 2. Okay, I'll go back to condition number 2. Remember what I said? I only talked about the first one. Condition number 2 only works if condition number 1 works. So condition number 2 says, whatever you put for G, which is the first box, ends up being the domain for the entire composite function. So hence why they say this will equal that. Okay? And that's why I wrote the other way around, because I knew G is coming first, hence it's domain of G, and this is the overall function. That was a big lesson. Okay? So I know it's a rushed session. Usually we would practice all the other skills like number lines and set notations, function notations. Domain and range, for those who don't know domain and range, that was all A, B, C, D. Okay? Now when I'm starting on E, I'm assuming that you can sketch. Assuming you understand range and domain, I assume that you understand what a function is. There's a lot of assumptions here, so I know for some of you, that might have been a lot of info. Okay? But that's a key exercise for only one question that might occur in an exam. Might. Okay? I'm going to stop the video there so you can get a bit of a breather, and it's 9:46, so you've got about half hour that is yours that you can then ask me questions, anything about OneNote, etc. I'm going to stop the video.